This is concrete. Everyone knows concrete. It is used to build houses, roads, bridges, and so on. Concrete is mainly composed of cement powder, water, sand, and gravel. There can be other components, but these are the main ingredients. The components are mixed together to form concrete, and the mixture then gradually hardens as it dries. We can pour the mixture into a mold to obtain the desired shapes before it hardens. However, as time passes, concrete can crack and large cracks can become really dangerous. So we need to find a way to repair it before the building collapses. But how? There are many ways that engineers have thought of to repair the concrete. The first way is mixing cement powder with water and spread it across the crack. But did you know that manufacturing cement is the cause of 5 to 7% of CO2 from all the CO2 that is emitted around the world? So in order to save the environment, engineers are trying to avoid these methods. The second way is adding chase memory additive that helps limiting the crack width. When cracks occur, the additives such as fiber will be pushed and bent. But when we provide heat, the fiber will strengthen back, making the cracks to become smaller. By adding fiber, the crack will be small enough to let the concrete heal itself. But how? Usually there will be some amount of cement powder that haven't reacted with water left inside the concrete, and when it does, it can become hardened and fill the cracks. Besides, there will be calcium ions in the cracks, and when it reacts with carbon dioxide and water, it can form limestone and heal the cracks as well. The third method is filling hollow glass fiber tubes with a chemical called polyurethanes or PU as the liquid healing agent. When the cracks occur in the concrete, this will cause the glass tubes to break and release the polyurethane to fill the crack. Yet there are a few problems to consider. Glass tubes are brittle and will easily break during the mixing process. This makes implementing the PU tubes rather difficult to implement. Furthermore, cracks do not always occur across the paths of the tubes, so the tubes won't break and the PU is not released. The advantage of PU is that it's extremely flexible and can withstand the reopenings and closing of the cracks. No water is required for the process to happen. The fourth method is adding SAP or super absorbent polymer to the concrete mix. This polymer can store a great amount of water during drying period. The SAP slowly releases the water into the concrete and provides further hydration of cement particles and the limestone precipitation. This method would be useful for water-retaining structures such as swimming pools or underground tunnels, since it requires water to work. The fifth method is adding bacteria into concrete. These bacteria help boost the production of limestone, a healing agent that has similar properties to concrete. The bacteria we use belong to Bacillus species. We utilize this Bacillus because it's surrounded with negative charge that attracts the positive charged calcium ion, an important component in the formation of limestone. We are going to present 5 methods of how to use bacteria in healing concrete. First one is adding bacteria into lightweight aggregates, adding bacteria into hydrogel, adding bacteria into silica gel, adding bacteria into polyurethanes, and last one is adding bacteria into micro capsule. This may sound challenging, but it's actually quite simple and really interesting. What are lightweight aggregates? Lightweight aggregates are clay particles with a tiny 0.5 mm size with an excessive amount of pores. By adding bacteria, spores, and their nutrition into the pore of the lightweight aggregates, these bacteria's added aggregates are used to replace some amount of sand during concrete mixing. This spatial aggregate samples found by researcher is ceramide, which has more strength than typical clay particles. This in turn makes concrete stronger. And how does this type of aggregates help healing the cracks in concrete? When the cracks occur in concrete, some aggregates would be broken as well, causing the spores to come out from the aggregates and become exposed to moisture and grow into bacteria. These bacteria would be feeding off the added nutrients and use these nutrients to produce limestone and heal the cracks in concrete. With this method, spore of Bacillus spirochetes are added into hydrogel. Hydrogel can contain a significant amount of water. This helps in the growing of spore into bacteria. Let's look at how the spore are prepared. First, the bacteria are put into the test tube with nutrients. These bacteria are left alone until the spores are produced. The test tube would then be put into the centrifuge, which spins at high speed. This process will separate out the spores. Afterward, the spore will be pasteurized, which is the process of heating to kill unrequired bacteria and to preserve the spore for future usage. The spore would then be stored at 4 degrees Celsius. The process of making hydrogel capsules is as follows. We need hydrogel's initial substances, yeast extract, bacteria spores, calcium ion substances, urea. Mix well together. Pour onto a petri dish. Stir with UV radiation. A 0.1 mm hydrogel layer is then produced. Match it at freezing temperature until tiny flakes of hydrogel capsule are made. These hydrogel capsules would then be added during the mixing of concrete. When a crack occurs in the concrete, moisture would then be able to seep in. The hydrogel will absorb the moisture, making urea become reactive to water. This creates carbonate, which is an essential substance of limestone. Bacteria will release the accelerating chemical, ureas. Ureas will accelerate the reaction. Bacteria also have negative ion around them. They will attract the positive calcium ion, and now bacteria will be surrounded by calcium. Calcium ions combine with carbonates and becomes limestone. Limestone helps by filling the voids and heal the concrete. What is silica gel? Silica gel is gel that possesses these properties: ability to control pH, temperature change tolerance, stability in terms of mechanics and chemistry, bacteria attacks resistant, contain adequate amount of pores so that molecules of iron can pass through. Researchers combine silica gel with Bacillus sphaericus and put them into a test tube and attach this tube to another tube that contains nutrition, which is urea and substances that contain calcium ions. These two chemicals help produce limestone. These tubes would be arranged in layers during concrete casting. When concrete breaks, these tubes would break as well. The spore will feed off the adjacent nutrients and eventually produce enough limestone to heal the concrete. What if the nutritions tubes break before the silica gel containing bacteria tubes and the nutritions leak then? Without nutritions, bacteria that leaks afterward won't be able to survive and finally die. This method is similar to the previous methods. 3 glass tubes are filled with 3 different substances: polyurethanes, bacteria Bacillus sphaericus, nutritions, and similar to silica gel methods, the glass tubes are placed in layers while casting the concrete. When glass tubes break, 3 substances will mix together and bacteria can finally produce limestone. Why is polyurethanes needed? Because it has these properties: pH controllability, flexibility like a rubber, bacteria resistant, water resistant. The disadvantages of these methods is that these tubes can only be used one time. After breaking and forming the first round of limestone, there would be no more backup healing bacteria. This method is similar to other methods that insert bacterial capsule into concrete and eventually creates limestone and heal the concrete. But with these new methods, microcapsules are used instead. These microcapsules are made from melamine formaldehyde. And how is this melamine formaldehyde made? We start with melamine formaldehyde chemicals. During melamine formaldehyde mixing, spore bacteria are added. When the reaction is completed, microcapsule with bacteria inside would be formed. Properties of these microcapsules: regular round shape, resistant to high pH, impervious. With moisture during concrete mixing, microcapsule would be flexible and will not break right away. After concrete hardening, there would not be enough moisture for the microcapsule to have stable shape and would become brittle and break, releasing the bacteria. Using bacteria to heal concrete still has its limitations, such as only small cracks can be healed with this technology. These above-mentioned methods may not be the best solution at present, but there are still many more developments that can be researched and used in the future. Thank you for watching.